Okay, have you ever looked up at the night sky and just thought about how huge the universe is?
Yeah.
And then it hits you, right? Like, are we really all alone out here with all these stars and galaxies?
Yeah, it's a pretty wild
I mean,
thought.
that's basically the Fermi Paradox, isn't it? It's like this crazy gap between how likely it seems that alien life should exist and the fact that we've never found any proof of it.
It really is, and it's a puzzle that's been bugging scientists and philosophers for I don't know how long, decades, right?
Yeah.
You'd think that with all those stars out there, at least some of them must have planets with life, right? Intelligent life, even.
Totally. And if they're out there, you'd think at least one of them would have tried to get in touch by now.
Yeah, exactly.
But the paper we're looking at today, it's called Eternity in 6 Hours. Well, it says the paradox is even weirder than we thought. It argues that a super advanced civilization, well, they could colonize the entire universe pretty easily.
And not just possible, but shockingly easy.
Oh,
Yeah, and what I find really interesting about this paper is that it tackles the whole thing from a practical point of view, almost like an engineering problem. Like it lays out the steps a civilization would need to pull it off.
okay. I'm intrigued.
And the key to their whole argument, self-replicating probes.
So, tiny spaceships?
Kind of, they'd travel across the galaxy and they could build copies of themselves using stuff they find at their destination.
So, like a space 3D printer or something.
Yeah, exactly. Instead of having to transport all the materials for building a galactic empire across these vast distances, you just send the instructions and a little machine that gathers what it needs and just starts building.
Wow, okay. That is clever. But even with that, wouldn't you still need an insane amount of energy just to send these probes across the universe?
Of course. And that's where things get really interesting. The authors of this paper suggest that a civilization could capture even just a fraction of their star's energy. Think of it like a Dyson sphere. And that's all they'd need to send these probes everywhere.
A Dyson sphere. That sounds like pure science fiction. Like that massive structure built around a whole star to capture its energy,
You
right?
got it. But to be realistic, they're suggesting more of a Dyson swarm. So a bunch of smaller solar collectors, kind of like a cloud of tiny power plants orbiting the star.
So instead of one giant thing, thousands or even millions
Yeah.
of smaller ones all working together.
Right.
Okay, does seem a bit more manageable, but wouldn't you still need an absurd amount of resources to build all that?
Well, the paper suggests using materials that are already out there. Like they actually talk about dismantling a whole planet, something like Mercury, to get what they need.
Dismantle an entire planet? Oh, come on.
Yeah.
Even for a super advanced civilization, that seems a little extreme, doesn't it?
I know, right? It sounds pretty crazy. But we're talking about a civilization with technology so far beyond ours. On a cosmic scale, a planet might just be like another resource.
Yeah, okay. I'm starting to get it now. So you've got these probes, a Dyson swarm for power. But hold on. How do these little probes actually slow down once they reach another galaxy? I mean, wouldn't they just zoom right past at almost the speed of light?
Good question. The paper looks at a few different options. One idea is magnetic sails, using the galaxy's magnetic field to slow down, but they mainly focus on a more familiar concept, rockets.
Rockets. But wouldn't you need an insane amount of fuel to slow down from those speeds? We're talking interstellar travel here, not just a trip to the moon.
Exactly. The authors consider three types of fuel, each with its own pros and cons. Two of them you might have heard of, fission and fusion things we've already played around with on Earth. But the third one, now this is where it gets really wild, antimatter.
Antimatter. Now that is straight out of science fiction. It's that stuff that destroys matter on contact, releasing a ton of energy, right?
Exactly. Antimatter is still pretty theoretical, but it could be the most efficient rocket fuel imaginable. The paper even mentions some research suggesting antimatter rockets could reach a level of efficiency way beyond anything we can do now.
Wow. All right. So we've got these probes flying across the universe almost as fast as light, powered by antimatter rockets. But how do we make sure they even survive the trip? Space is a pretty rough place. Even a tiny speck of dust could wreck everything at those speeds.
Another great point. And the authors address that too. Their solution is redundancy. Send out a whole bunch of probes at once. They calculated that for a probe going at 99% the speed of light, you'd need to launch about 40 to make sure at least one gets to its target galaxy, and that way, at least one of them is bound to make it.
So basically, a cosmic shotgun approach. Fire enough, and some are going to hit the target.
Pretty much.
But, okay, let's say these probes, they make it to another galaxy, they manage to slow down. What happens then? What's the whole point of this huge effort in the first place?
Well, that's where the paper gets really philosophical. It starts to explore why a civilization would even want to do this. Why go through all this to spread across the universe?
Yeah, that's a good question. I mean, when I think of colonizing space, I think of finding new resources, maybe escaping a dying planet, or even just conquering new worlds. But I have a feeling this paper might have some deeper ideas in mind.
You're right on the money there. They suggest a bunch of reasons that might seem kind of strange to us at first. Like, one idea is survival, spreading out so they're not all wiped out by some big disaster, like, I don't know, an asteroid or even some kind of internal conflict.
Okay, yeah. Kind of like a cosmic insurance policy.
Exactly. Don't put all your eggs in one
Right.
basket.
Right. So if you're a civilization that's really advanced, you'd probably want to protect yourself from, well, anything that could wipe you out.
Yeah, and it doesn't even have to be about escaping a dying planet or anything. It's more about making sure their species or their knowledge survives, across space and time.
Like a cosmic backup for your hard drive.
Exactly.
Okay, that makes sense. But are there any other reasons they might want to expand? Besides just surviving, I mean.
Well, they also talk about the idea of escape.
Hmm.
Like, maybe some groups within a civilization might want to break away, start fresh somewhere else, or get away from whoever's in charge.
So it's not necessarily about conquering new worlds, but more about finding freedom or refuge.
Yeah, exactly.
Huh. Makes you wonder what kind of problems or conflicts would push a civilization to go that far.
Yeah, and it shows that we can't assume all these advanced civilizations would think or act like us. Their reasons for colonizing the universe might be totally different from ours.
That's a good point. This is all pretty fascinating. It really makes you think about all the possibilities. But honestly, this whole idea of an advanced civilization spreading across the universe, it just makes the silence we're hearing even more puzzling.
Yeah, you're right. It really gets to the heart of the Fermi Paradox. I mean, if it's so easy to colonize the universe, where is everyone? Why haven't we seen any sign of these galactic empires or their probes?
It's like looking for footprints on a beach and finding nothing. Makes you wonder if anyone's ever been there before.
Well, this paper actually suggests that the very act of colonizing the universe might be why we haven't found anyone. They say these advanced civilizations could be choosing to stay hidden.
Intentionally hiding. Now, that's a wild idea. Why would they want to do that?
Yeah.
Is this like some kind of cosmic game of hide and seek?
Not exactly, but it's not as crazy as it sounds. They talk about a few ideas that are already out there, like the zoo hypothesis, which says advanced civilizations might avoid contact with less developed ones on purpose.
So we're like the cosmic equivalent of an uncontacted tribe deep in the Amazon or something. They're watching us from afar, studying us without interfering.
Maybe. The idea is that they're not doing it to be mean or anything. It's more about ethics or maybe even self-preservation. Imagine how crazy it would be for us if a super advanced alien civilization suddenly showed up.
Yeah, it would probably cause chaos.
Totally. And from their perspective, trying to talk to us might be like trying to have a deep conversation with a toddler. They might see us as too primitive or unpredictable to engage with directly.
So they're happy to just watch us from a distance, waiting for us to, well, grow up a bit.
Could be. And this actually connects to another hypothesis called the interdict hypothesis. It says there might be some kind of galactic federation or council that has a rule against contacting less developed civilizations.
Like a galactic UN, keeping the peace and preventing chaos.
Something like that. The idea is that this federation sees us as too volatile, maybe even dangerous, so they've basically quarantined us until we reach a certain level of, I don't know, technological or ethical maturity.
So until we stop pointing nukes at each other and figure out how to deal with climate change.
Right. It makes you think about what their standards for contact would be.
For sure. But these are all just theories, right? We don't have any hard proof.
Exactly. But they do give us some interesting ways to think about why we haven't found any other civilizations, even though colonizing the universe seems possible.
Yeah, it's like trying to solve a mystery with only a few clues. We're making a lot of assumptions about what a super advanced civilization would be like and how they'd act.
Exactly. We're trying to understand beings that could be millions, maybe billions of years ahead of us in terms of intelligence and technology.
It's kind of humbling and exciting at the same time. But, okay, let's say this cosmic secrecy thing is real. What kind of evidence could we even look for? If they're so good at hiding, wouldn't they make sure we never found them?
That's the big question. If a civilization can colonize the universe, they can probably hide pretty well too. But there might be some subtle clues we could pick up on.
Like what? Are we talking hidden alien bases on the moon? Or secret messages in our DNA?
It could be something like that, but probably more subtle. Maybe weird energy readings from our telescopes, strange patterns in space that don't make sense naturally, or even tiny changes to our environment that we haven't noticed yet.
So we're looking for things that make us go, hold on, that's not right.
Exactly. It's like looking for a needle in a haystack, except the haystack is the entire universe.
Talk about a challenge. But okay, let's imagine we do find something. Then what? What happens if we discover we're not alone and that someone's been watching us all along?
That's a huge question. It would completely change how we see ourselves and our place in the universe. We'd have to face the fact that we might not be the most intelligent or advanced beings out there, and that we might not understand reality as well as we think we do.
It would be like finding out the play we thought we were starring in is actually just a small part of a much bigger story.
A huge shift in how we see things. We'd have to accept that we might not be the smartest ones in the universe, and that our understanding of everything might be way off.
It's mind-blowing, but also kind of scary. If we're being watched, does that mean we don't have free will? Are we just pawns in some cosmic experiment?
Whoa, that's a deep question. But even if we are being observed, it doesn't necessarily mean we don't have free will or that our choices don't matter. We can still try to be our best and make a difference in the world, regardless of whether anyone's watching.
So even if we're in a cosmic zoo, we should act like we're the only ones in the audience.
Exactly. And maybe, just maybe, by searching for others and trying to understand them, we'll learn more about ourselves along the way.
This deep dive has really opened my eyes to the Fermi Paradox and just how much we don't know.
Mm.
We've talked about self-replicating probes, Dyson spheres, galactic federations, cosmic hide-and-seek. It's a lot to take in.
Yeah, it really pushes the limits of what we can imagine and makes us question everything we thought we knew about the universe.
But even without all the answers, this has definitely given me a new perspective on our place in all of this. So we've been talking about these crazy ideas like civilizations colonizing the universe and maybe even hiding from us on purpose. It really makes you wonder if everyone else knows something we don't about this whole cosmic game of hide and seek.
Yeah, it's a fascinating thought for sure. But for a minute, let's step back from those more, well, speculative ideas
Okay.
and consider some other explanations for the Fermi Paradox. They might not be as exciting as alien empires and galactic federations, but they raise some really big questions about, well, about our place in the universe.
All right, I'm ready to hear the other side of the story. What are some of these alternative explanations that don't involve aliens playing hide and seek?
Well, one possibility is that the conditions for intelligent life to evolve might be way rarer than we think. It's called the rare Earth hypothesis, and it suggests that we might just be incredibly lucky to exist at all.
So you're saying Earth might be like a cosmic unicorn, a planet with this perfect set of conditions that allowed complex life to form.
Yeah, that's the basic idea. I think about all the things that had to line up just right for us to be here. The size and stability of our solar system, having a big moon to stabilize our planet's tilt, the right mix of elements, even those big asteroid impacts, they could have played a role in how life evolved on Earth.
Wow. It's like winning the cosmic lottery over and over again.
Right. And if that's true, then the chances of finding another planet with intelligent life are, well, pretty slim.
It's kind of humbling and a little lonely if you think about it. But okay, let's say intelligent life isn't some 1 in a trillion chance. What are some other reasons we haven't seen any sign of alien civilizations?
One possibility, and it's not a very happy one, is that maybe civilizations just tend to destroy themselves before they get to the point where they can travel between stars.
The classic "we blew ourselves up" scenario. It wouldn't be the first time a species went extinct because of its own actions.
Sadly, no. Look at our own history. We've developed incredibly powerful technology in a really short time. Nuclear weapons, genetic engineering, artificial intelligence, but we haven't always been very responsible with it.
Yeah. It's not hard to imagine a civilization inventing something that ends up destroying them. Maybe a supervirus, or a runaway climate catastrophe, or even some self-replicating AI that turns against them.
Exactly. And it just shows how fragile civilizations can be, especially if they advance technologically without developing the wisdom to go with it.
So maybe we haven't met any aliens because they all ended up destroying themselves. Kind of like a cosmic version of survival of the fittest, where only the most careful and self-aware civilizations make it.
Yeah, it's a chilling thought, but it could be true. And this idea ties into something called the Great Filter. It's like a barrier that prevents most civilizations from reaching a certain level of technology or surviving long enough to make their presence known across the galaxy.
A great filter. That sounds kind of ominous.
Yeah.
What exactly is this filter? Is it like a specific technological problem they can't solve?
Mm.
Or just a general tendency for civilizations to self-destruct?
That's the scary part. We just don't know. The great filter could be something we've already passed, like figuring out how complex life emerges in the first place. Or it could be waiting for us in the future, like some technology that inevitably leads to our downfall.
So either we're incredibly lucky to have made it this far, or we're about to step on a cosmic banana peel.
That's one way to put it. And the scariest part is we don't know which one it is. Are we the exception? Or are we on the verge of destroying ourselves?
Okay, that's giving me some existential dread.
Yeah.
But if we don't know where we stand with this great filter, how does that change how we think about searching for extraterrestrial life?
Well, it adds a really interesting twist. Some scientists actually think that finding evidence of even simple life, like microbes, on another planet could be bad news.
Wait, how could finding life be a bad thing? Isn't that the whole point of looking?
It would be an amazing discovery, for sure. But think about it in terms of the Great Filter. If life is common, then that means the filter probably isn't behind us. It means it's likely still ahead.
Oh. So finding a planet full of microbes would suggest that the real challenge, the thing that wipes out most civilizations, is something we haven't faced yet.
Exactly.
Okay, yeah, I can see the logic there.
Yes.
So the more planets we find with life, the more likely it is that we're heading for some kind of cosmic dead end.
In a way, yes. But on the other hand, if we keep searching and don't find any signs of life anywhere, it could actually be a good thing.
Really? So finding nothing could be the best possible outcome. That seems a bit backwards.
It does, I know. But if we are truly alone in the universe, it would suggest that the hardest part, the thing that filters out most civilizations, is already behind us. It would mean we have a wide open future to explore and maybe even become a species that travels between the stars.
Wow, this whole conversation has really flipped my thinking about the Fermi Paradox. It's not just about if aliens exist, it's about what their absence or presence means for our future as a species.
Exactly. It's a humbling and thought-provoking paradox that makes us think about how big the universe is, how fragile our own existence is, and all the unknowns that lie ahead.
This has been one of the most mind-blowing deep dives we've ever done. We've gone from self-replicating probes and Dyson spheres to galactic zoos, existential threats, and the possibility that we're either incredibly lucky or incredibly doomed. I don't know about you, but I need a minute to process all of this.
I think we all do. The Fermi Paradox isn't just a scientific puzzle, it's a philosophical question that makes us think deeply about our place in the cosmos, what intelligence really is, and the future of humanity itself.
It reminds us that we're just starting to understand the universe, and that every answer we find leads to even more questions. But that's what makes exploration so exciting, right? The journey is just as important as the destination.
I couldn't have said it better myself. So we'll leave you to ponder the mysteries of the universe. Until next time, keep looking up and asking the big questions. Who knows what amazing and maybe even terrifying discoveries are waiting for us?